Good afternoon, class 10. In the previous portion of chapter 6, we have learned about the visible spectrum, right? That is the VIBGYOR portion. We have learned that white light splits into 7 constituent colors, visible band of 7 colors forming VIBGYOR. So, it ranges from the wavelength 4000 Armstrong to 8000 Armstrong, right? 4000 being the wavelength of violet least and red being the 8000. Red color has the maximum wavelength, right? So we have learned this from 6a. Now, it was found that beyond the visible spectrum also there lies certain radiations which are not visible to us with our naked eyes. So that forms the invisible spectrum. So just see, beyond the red end of the VIBGYOR we have invisible spectrum, and beyond violet end we have invisible spectrum. Beyond red, the spectrum which we have is the infrared spectrum. Why? Because it starts with the infrared. Infrared, that means wavelength greater than the wavelength of red color of white light. See, it's greater than 8000 Armstrong. So, it has certain range 8000 to 10 to the power 7. Then beyond infrared we have microwave, which is having wavelength even greater than the infrared. Then we have radio waves. See the wavelength, the ranges of the wavelengths, it's increasing from the red end. And beyond the violet end, we have wavelengths lesser than the wavelengths of 4000 Armstrong. See, that's why we call it ultraviolet, because its wavelength is less than 4000, which is the wavelength of violet light. Less than 4000, 100 to 4000, below which we have X-rays 0.1 to 100, less than 0.1 we have gamma rays. So just see, you are getting wavelength in the increasing order from this end to this end. See, it's increasing in the order like this, the wavelengths. Gamma rays, X-rays, ultraviolet, then we have the visible range, violet to red, among which violet has the minimum wavelength, red has the maximum. Then infrared, microwave, radio wave, right? And this entire spectrum is known as electromagnetic spectrum. Okay, I've mentioned the wavelengths in Armstrong, but you can also mention in nanometer. By knowing the relation 1 nanometer is equal to 10 Armstrong. Okay, we can just convert it to nanometer also. And if wavelength increases in this order, frequency will increase in this order, right? Because V equal to F into lambda. If V is constant, then F is inversely proportional to lambda. So, just see, the frequencies are decreasing. In this order, if you see, frequencies are decreasing. That means frequencies are increasing in this order. Okay. So now, let's look at the common properties of electromagnetic waves. The waves in this region, electromagnetic spectrum, these are known as, they constitute the electromagnetic waves. Okay. So, the common properties to all these electromagnetic waves are, they can travel through vacuum, right? And in vacuum their speed will be 3 into 10 to the power 8 meter per second, the speed of light. And they will exhibit properties like reflection, refraction when they passes from one medium to another medium of different optical densities. They are transverse waves. What are transverse waves? The waves that are produced in a medium When particles of a medium, they vibrate perpendicular to the direction of propagation of wave in a medium. Sound waves are longitudinal, but electromagnetic waves, these are transverse waves. And see, these waves are not deflected by electric and magnetic field. Now you will learn this when we'll do also the electromagnetism chapter, that a charged particle is always deflected by electric and magnetic field. That means these waves are not deflected by electric and magnetic field because these are not carrying any charge. Okay. So as a whole, basically they are electrically neutral then. Now let's look at some properties of ultraviolet and infrared radiations important for this chapter. Okay. Now see, I have written some common properties. First of all, if you get in the exam that mention some common properties between ultraviolet and infrared radiation, some of the common properties which are already mentioned are which one? These. Okay, because this comes, and if these are the common properties of electromagnetic waves, that means these are the common properties of ultraviolet and infrared also. Apart from this, some other common properties are ultraviolet radiation is absorbed by glass, but it can pass through quartz. This actually, these are basically used in detection purposes of ultraviolet and infrared radiations. And infrared is also absorbed by glass, but it passes through rock salt. Okay. Now you will find that there are some other properties which are different in both of them. That means basically ultraviolet and infrared varies in this points. See, ultraviolet, this strongly affect the photographic plate, whereas infrared does not affect the photographic plate. That is why infrared rays are used in dark rooms for developing the photography, as it does not affect the photographic plate. Okay. See, then the ultraviolet rays causes fluorescence on zinc sulfide screen, but it does not cause any fluorescence. Ultraviolet rays produces heating effect. Infrared does not produce. Ultraviolet rays do not produce heating effect, whereas infrared rays produce strong heating effect. Now, the next point, see. This we have learned already in chapter 6c, that the intensity of scattering is inversely proportional to the fourth power of wavelength. So, see, the ultraviolet has less wavelength, right? Lesser wavelength. Now, if wavelength is less, that means intensity of scattering will be high. Whereas for infrared, wavelength is much more, right? That means if wavelength is much more, then intensity of scattering will be much less, inversely proportional. That is why they can penetrate larger distances even in mist and fog, and this is the property which enables them to use the infrared radiations in photography at night or mist or in fog. Okay. These are the applications of infrared. Now, one common source of ultraviolet and infrared radiation will be sun. It's a common source for both of them. Now, see, this is also important, okay? Distinction between ultraviolet, visible and infrared radiations. Because, see, if you get the questions like what are the common properties between ultraviolet and visible radiation or visible or infrared, common properties always follow that those common properties of electromagnetic radiations. But say if you are asked to write the difference in their properties like that, so then follow these points. Okay, just go through these points. Apart from this, see, microwaves, you can get some objectives like satellite communication, the waves used for satellite communication, microwaves. Obviously, these are the waves used for microwave ovens. This you all know because the name suggests. Radio waves used in radar communication. Now gamma rays, we will do gamma rays in chapter 12, radioactivity, but just for the time being, we will learn that in radioactivity, that nucleus, this gamma emission, alpha emission, beta emission, these are all the emissions. These are basically nuclear phenomena. Okay, nucleus of radioactive elements, they emit 3 types of radiations. Okay, the radioactive elements, the atoms, the nucleus of the radioactive elements, they emit 3 types of radiations. Alpha, which is the positively charged, beta, it's the negatively charged, and gamma is actually chargeless. So we will do this in chapter radioactivity also, and properties also we will do that. So basically you will find that the sources, under source it's written that it's emitted when it passes from excited state to the ground state. So this we will learn when we will do chapter 12, radioactivity. Now few applications of gamma rays, you will find that gamma rays are used in radiotherapy. Why? To kill the cancer cells, because gamma rays have strong penetrating power. They can penetrate easily through the human body. That is why they can also cause immense damage. The damage caused by gamma rays is maximum, then followed by beta, then followed by alpha. What about the X-rays? X-rays, where are they used? They are used to detect the fractures in bones or teeth, etc., which is known as radiography. Why? Because they can penetrate through the human flesh but not through the bones. Now from this portion, you can also get questions like arrange the, say, ultraviolet, infrared, microwave in the increasing order of the wavelengths or decreasing order of the wavelengths, like that. You are asked questions like this also, okay? So you have to remember this order.